Today, we're diving into something pretty mind-blowing in the world of artificial intelligence. It's called Perception-Informed Neural Networks, or PrINNs for short, and it's all based on some seriously cool work by Mehran Mazandarani and Marzia Najarian.
All right, let's just jump right in with a big question. What if we could teach an AI to learn not just from crunching trillions of numbers, but from a hunch, from an expert's gut feeling or just a simple human observation? That's the core idea we're going to unpack.
So to really get what's so new and exciting here, we actually have to take a quick step back. We need to look at a huge breakthrough that happened a few years ago. You can kind of think of it as the moment AI went and got itself a physics degree.
This big idea was something called physics-informed neural networks, or PrINNs. Now, instead of just feeding an AI a mountain of data and hoping for the best, researchers started teaching it the fundamental laws of science. Things like mechanics, thermodynamics, written out as precise mathematical equations. This was a huge deal because it meant the AI's predictions had to actually obey the known rules of the universe.
So what this all means is that PrINNs are absolutely fantastic when the rules of the game are perfectly clear and certain. They force the AI to stick to what we've already proven to be true, which makes the models way more reliable, especially if you don't have a ton of data to work with.
But, and this is a big but, that total reliance on perfect, crystal-clear laws, well, that's also its biggest weakness. Because let's be real, in the messy, real world, the rules are almost never that simple.
I mean, just think about it for a second. How would you write a perfect, neat little equation for the stock market? Or for the way societies change and evolve? Or for a super complex biological system where a million different things are happening at once? The short answer is you can't. These fields are all about uncertainty, complexity, and just plain old human behavior.
And this slide really lays it all out, doesn't it? On one side, you have PrINNs, which are built for certainty. They're amazing with a single source of truth, hard physics laws. But on the other side, you have this huge need for something that can handle the messy stuff, the uncertainty, the different opinions, the perception-based info.
And that is exactly where this new idea comes in. This is the moment we stop just teaching AI physics and start teaching it something a little more human. This is where we introduce perception-informed neural networks.
So, what are PrINNs? Well, think of them as the next evolution of PrINNs. They create this incredible framework that can absorb not just those hard and fast equations, but also all that fuzzy perception-based information. We're talking about an expert's educated guess, a scientist's casual observation, or even just a simple description like, the system seems to be behaving strangely.
Okay, so you're probably wondering, how in the world do you get an AI to understand something as vague as the pressure is kind of low? Well, the secret sauce here is a process called precision. This is the magic key that unlocks the whole thing. It's a way of translating our fuzzy, everyday language into a structured, mathematical format that a neural network can actually work with.
And the process itself is actually pretty straightforward. You start with a perception, right? Like an engineer saying the initial condition is somewhere near zero. That fuzzy statement then gets turned into a more formal proposition, and finally, it's structured as what's called a generalized constraint. This constraint then acts like a flexible guideline for the AI, kind of like how a physics law would for a pin.
Now, what's really cool is that PrINN isn't just one single model. Because there are so many different kinds of perception and uncertainty out there, it's actually a whole family of powerful, specialized AI models designed for different jobs. I mean, this framework is just so versatile. You've got your classic PrINNs for when you're sure about the rules, but then you get into these other incredible variations like FPrINNs that are designed to handle fuzzy info, or check out MOINNs, which can actually combine different, maybe even conflicting opinions from multiple experts. There are even FINs, which are made to model systems where you don't know the equations at all, and you're just going off of perception-based if-then rules.
And this is where it gets truly mind-bending. By being able to intelligently combine different types of uncertain knowledge from different people, these models can do more than just solve problems we already understand. They could, potentially, discover entirely new laws of science, brand new differential equations that no one has even thought of yet.
This idea didn't just appear out of thin air. It's been a long journey. The conceptual groundwork was really laid down decades ago by Lofty Zeta and his work on uncertainty. That amazing research eventually led us to PrINNs around 2017, and now, here in 2024, to the formal introduction of the entire PrINNs framework, which just might open the door to a whole new era of scientific discovery.
Okay, so let's bring it all home. Let's really talk about why this is such a fundamental shift in how we think about AI and science. Why is this such a game changer?
So why does all this matter? Well, because for the first time, we can build serious models for all those messy, complex systems that don't have perfect equations. We can do it by plugging invaluable human expertise and intuition right into the AI itself. This approach finally bridges that old gap between purely data-driven AI and knowledge-based systems. What we get is a much more robust AI for the real world, and maybe most exciting of all, a brand new platform for scientific discovery.
In the end, the researchers who created this sum it up perfectly. This framework is a huge step forward. It's about creating a true partnership between the solid laws of physics, modern data science, and the totally irreplaceable power of human perception.
So that leaves us with this one huge, exciting question to think about. Once we've finally taught our most powerful computers to understand not just data, but perception itself, what incredible new frontiers of science are we going to discover?